Okay guys, so mini lesson 3 is a review, really ties into what we were learning about exponential functions. We're going to look at a word problem and you're going to see connections to that PERT formula we did in the beginning of chapter 5. Remember that A equals PE to the RT. So that really ties in nicely to a word problem that connects to the real world. We'll take a look at this. Here is the word problem we're going to look at. So, spread of a virus, very relatable, right? The number of MRSA cases has been rising sharply in England and Wales since 1997. In 1997, 2,422 cases were reported. The number of cases reported in 2003 was 7,684. How many cases will be expected in 2020? And then it says, let t equal 0 correspond to 1997. Use this formula, n equals n sub 0 e to the rt, where n represents the number of cases reported. Okay, word problems. Just like on SATs or anything, lots of information is given to us, right? So I'm not going to do anything before I understand all of this information. So let's take a look here, and I want to highlight this formula. This is the exact same thing. I hope you guys can make the connection to okay, I'm so bad at writing with this. A equals PE to the RT. All it is just giving different variables, right? So notice A is now N. Remember what A used to be? A used to be the total amount in an account, right? So here, N is the total number of cases reported. And P, anybody remember what P used to be? P used to be our initial deposit, right? The amount that was starting into our account. Now, N sub 0 is representing the first initial case on the very first day. All right, so let's make a connection between these two formulas, that they're the same, right? And now we're going to pull out some important information. So in 1997, we want to make sure that we know that's time 0, okay? I can write that as a point, right? At time 0, there were 2,422 cases. That is pulled right from the word problem. I didn't do any math. I'm just gathering my information. We can make a note here that, just so we're all on the same page, like this 0 is a t, that's time, right? And 2,422, that is my n sub 0, right? That is the first initial value, okay? Just like my initial deposit. At time 0, there were already 2,422 cases, okay? There we go. The next piece of information they gave us was in 2003, there were 7,684 cases. How did I get 6? Right? I go 2003 equals t equals 6. How did I get that? Right? Thinking about 1997 to 2003, how many years have gone by? 6 years, right? 98, 99, 2000, 1, 2, 3, 6 years. There's a 6. Okay? So that's how t equals 6. I can write that as another ordered pair when my time is 6. My n value, right? My total number of cases is 7,684. Again, so far I'm pulling out information. The question, right? Here is our question. We have to make sure I know what it's asking. How many cases will be expected in 2020? So I have to do even more math. From 1997 to 2020, that's 23 years. So that's how I get t equals 23. I can write this as a point, right? Here I know my time is 23, but the question says, what is my n, right? How many cases are there going to be in 23 years from now? That's what we're trying to find. So let's go back up to this equation, make sure we understand all of these variables. N, that's some value, the number of cases reported. N sub 0, that's my initial value, right? At the very beginning, how many cases were reported. E, why are we using this formula? Remember we learned 3 formulas. We're using this formula because it was continuously compounded. This is happening continuously. Data is being collected all the time. And my R is my rate, obviously, and my T is my time. So let's go through my initial thing that I know. All I know is that I'm starting with 2,422 cases. But I have to figure out when t is 23, what's my n? In order to write an equation, I need to know what this r is. That's what I have to try to find. So I'm going to plug in what I do know, right? This is the piece of information, whole information, right? I know this t and n. So that's what I'm going to go ahead and plug in. When time is at 6, the total number of cases are 7,684. And then, excuse me, and then I'm going to go ahead and I can solve this for r, right? It's a one variable equation now. Solve for r. So we're going to solve this for r first by dividing both sides by 2,422. Remember the steps back in 5.4. You have to isolate the exponential term. My exponential term is right here. Here's my exponential term. I need to get it by itself. So if I divide both sides by 2,422, and I'm going to round to 3 decimal places, I'm going to get 3.173 equals e to the 6r. I wrote that better. Okay? How do I get my exponent, which has the variable in it, out of the exponent? Remember back to 5.4, I have to take the ln of both sides. Okay, why do I take the ln of both sides? Because now it allows me to use the power property. Let's write that. Take ln of both sides so I can use the power property. Let's get you to see this. Take ln of both sides so I can use the power property. Notice I took the ln of both sides, which allowed me to move this exponent to the front. And then I have 6r times ln of e, but that's a property ln of e I know is 1, which is why it wasn't there in the first place. Okay, so it's ln of e equals 1. That's why it wasn't there. I can take it out. And now I have to get r alone, and I know I just have to divide both sides by 6. And then you're going to type that whole entire thing right into a calculator. And you're going to get about, again, round to 3 decimal places, 0.192. There's my r. So now I can go back to this equation, my original equation, and write my 2 most important numbers in it. Let's move this up. N equals 2,422 e to the r 0.192 times t. This is an equation for the MRSA cases that have been rising in England and Wales. This is the formula that could be used. So now I can go ahead and plug in any value of t to figure out the number of cases. The value of t that I want to plug in, remember, is 23. So I'm going to go ahead, plug in 23 in for t, and now I can type this entire thing right into a calculator. 2,422 e to the 0.192 times 23. If you don't have a calculator, you can use Desmos is perfect for this. You could just type that right into Desmos. So now I know there are 200,455.774 cases reported. I could round up to 200,456 cases reported. But this is the steps that you have to go through in order to solve a word problem connected to the real world. Okay, writing the equation, taking out the important information, solving for a missing variable, and then using it to figure out what I want. Okay, these first 2 steps are really important here, making sure we understand the formula and the key information. Okay, so you guys are going to practice this. I have a similar word problem in the practice section. Good luck, guys. You got this.